So, we've got our 4 apples to 2 pears. What about plate 2? Apples to pears. Olivia? 6 to 3, right? We've got more there. Plate 3 is going to have a proportional relationship to all the other plates that we've seen. So the relationship of how many apples I have compared to how many pears really looks like 4 to 2, 6 to 3. I've got twice as many apples. So Shahib, what would be my ratio for plate 3? What should it be? What would it be? What would we expect? Well, apples has to come first. So if I have 1 apple, how many pears would I expect to have? Zach? Half a pear. So if we kept those relationships proportional, so we had like 4 over 2 is the same as 6 over 3 is the same as 1 over 1/2. So that gets in the fact of we don't like fractions within fractions. It's one of like my biggest annoyances, especially when they're written like this. When the fraction bar in the fraction is not written diagonally, we don't like it. So we're going to deal with today of how do I deal with ratios or unit rates that involve fractions. Olivia?
Why couldn't it be 2 to 1?
It can be. And that's the whole point that we're going to see here is instead of using 1 to 1/2, we'd rather use 2 to 1. But then we'd have to have another apple here, and then we could have our other pair, or however you draw a pair.
Wait, would you like write a mixed number to write it at?
You only use a mixed number if my numerator is larger than my denominator. Now, 1 compared to 1/2, yes, my numerator is larger than my denominator, but there's no like easy, there's no way to write that mixed. There is a way to write it whole. It's just 2. But we want a comparison of one value compared to the other, so we say 2 to 1. Or in fraction form, we just say 2 to 1. So just hang on. We will see what all this really means. So the first thing that you have in your notes is showing us how we deal with having a fraction in the denominator. So this, I would like you off to the side of this because there's space to the left. Write 4/5 over 6 with that fraction bar in the numerator using the slash as opposed to the horizontal fraction bar. It makes it a lot easier to see. So that is where, if you have a highlighter, I would highlight. Multiply each term of the ratio by the denominator of the fraction, then write in simplest form. So that is why we have it set up like this. Now another option that we have here. I don't know who did. Oh, question? And Zach?
So why couldn't it be, like, couldn't you interpret it as like 4 over 5/6 if it wasn't?
Well, that would not be the same, like, that would not be what it's representing. That's why I said I don't like when they write it all stacked vertically. I don't like it that way. That's why I said you need to write this as 4/5 over 6, because that's actually what that's trying to show. 4/5 is your numerator, 6 is your denominator. I agree with you how it looks. It looks like it could be read either way, but you can't, like mathematically, you can't do this way or that way. It has to be one of them.
So there's like some rule that one has to be.
There's not really like a rule. It's just I don't like how Pearson writes it occasionally. Shahib?
I have sort of like a comment. The only reason you have to times it by 5 is because you have to cancel out the
Denominator of the numerator, right? So what Shahib is trying to tell us is my numerator is 4/5, my denominator is 6, and I don't like a fraction being involved in a fraction. That's also why, hey Rye, can you be with me please? That's also why we don't use decimals in fractions. Because I heard somebody say, oh, we can just use the decimal. We don't use decimals in fractions. It's wrong. Like mathematically, that's incorrect. So we have another option here. I could write 4/5 over 6 as 4/5 over 6 over 1, because can't 6 be written as a fraction, just 6 over 1?
Yeah.
Can't I take any fraction and write it in ratio form? 4/5 to 6 over 1. right? Like, have I broken any rules yet? Then, can't I just make it division?
Oh
Yeah,
my
because
goodness.
fractions is just division.
Because a fraction is just a division. So this fraction bar between my two fractions is really just telling me to divide. So when we have a ratio or a rate that involves fractions, we can multiply the numerator and the denominator. This is easier. By the reciprocal. And this is just about the same as keep, change, flip.
Okay, yeah.
What you're actually doing when you apply keep, change, flip is multiplying the numerator and the denominator by the reciprocal. But I'm going to show you why you're like, huh? Really? Like, that's more work than I thought it was. I'm going to show you why that actually is.
Is that how you spell reciprocal?
I think maybe.
R-A-C-I-P.
Oh, I think it's C-A-L. There's an A somewhere in there.
There's an A.
I think it's A-L.
That's how I spell it.
Pranav, you've had your hand up for a minute.
So, couldn't you just make the division sign longer, like longer than the other ones? Like, say
You guys keep asking about notation. Forget about the notation. I understand. Sometimes how Pearson presents it, not the easiest way. That's why we use the slash line. Like, yes, you're right, but we don't need to argue notation right now.
Okay, so I don't know if this will work with all of them, but I noticed that 5 times 6 is 30.
Ah, hang on to that thought.
Okay.
Hang on to that thought. So, if this will capture, so I can move on. So check this out. If I instead wrote this 4/5 divided by 6 over 1, well, the reciprocal of my denominator, since it's 6 over 1, would be 1 over 6. When I have 6 over 1 times 1 over 6, everything cancels out, and it just becomes 1. Anything divided by 1 is just what it started as. So, 4/5 times 1 over 6, numerator times numerator, gives me 4. Denominator times denominator gives me 30, and this just comes out to be 4/30ths, which reduces to 2/15ths, which is the same thing that we got down there. So if you click any of the help me solve this or the view and examples, they're going to show you if there's only one fraction in the fraction, find the denominator, multiply both by the denominator, and then simplify. Keep, change, flip is just as easy. Sheep?
What, who said something about, like, you have 50 times, I forget. Like, I tested it out with another number to see if it worked, and it does work, so.
Come on, come on.
We're going to move on. I'm going to pull the PDF for that one.
I did 3/4 over 6, and so I moved 4 to the numerator of the other number, and I did 6 times 3, and I got 18 for.
No, they were talking about the denominator times the denominator. If you did 6 times 3, you're...
No, I mean 24.
Okay, because this would actually be... Crap. So then if you multiply by 1/6, really multiply by 1/6, you get 3/24ths, which then can reduce again to like 1/8. Hey, let's practice some of these, and then your questions will get better. Like, what questions you have will make a lot more sense.
Okay.
Stop. Your neighborhood commute, or your neighbor commutes 12 miles to work, and you commute 9/10 of a mile to school. Write the ratio of your neighbor's commute to your commute as a fraction in simplest form. So, really, your neighbor's commute compared to your commute, 12 over 9/10. But we can make that easier if we think of 12 as being 12 over 1. Because now I have a fraction divided by a fraction, and I can just keep, change, flip to make my life easy. Really, I could have written this 12 over 1 in a ratio with 9/10, which I like the horizontal way of writing it out better. Like this method right here I like better, because when I set it up vertically, it's just kind of too confusing and busy. What Pearson would have you do is multiply by 10 on top and bottom, and then you'd still have to simplify and you'd still have to evaluate, because you'd get 120 divided by 9. Instead, you can just multiply by 10/9, which is the reciprocal of the denominator. 10 times 9 gives me 90. 9 times 10 gives me 90. They cancel out, and that would just make my denominator 1. Now I'd have 120 over 9. And I really just have 120 over 9. None of that actually needs to happen if I set it up like this and just apply keep, change, flip. I keep, I change, I flip, and I get 120 over 9. Okay. What is it? Yeah, it does simplify to 40 over 3.
You can cross cancel 12 and 9. It'd make it easier.
Back here we could have, but that would have just gotten us to 40 over 3. So yeah, you're right. We can either cross cancel before or reduce later. And then 40 thirds, really, I mean, if we want to talk about it in a decimal value. Sorry. 13. I don't know why I wrote 30. Well, I do know why I wrote 33. Because it'd be 0.3 repeating, or 13 and a third. So your neighbor commutes 13 and 1/3 times as far as you commute. Now, given you might be walking and they might be driving, but still, they're going over 13 times as far as you went. Zach?
Where's the change in?
This was really, when you set up a ratio is actually division. So the division changes to multiplication.
What if it was?
You don't, like, that's the only time you use keep, change, flip, is when you have a fraction divided by a fraction. So write the ratio of your commute to your neighbor's commute. Well, we can just say your commute is 9/10 divided by your neighbor's commute is 12. I can make that 12 over 1. I encourage you guys with all of this to just make them both fractions. I doubt my thermostat actually does. Borrow what? Why?
I don't have any writing utensils.
So you waited till now to tell me? I'll give you a pencil, because that's what you should have for every class. What, have you just been sharing a pencil with someone?
No. Then how do you, what? I just broke mine.
Ah, so don't break your things. So we keep our first fraction, change to multiplication, flip our second fraction. We get 9 over 120. That can simplify to 3 over 40. And really, we would leave it there. Your commute is 3/40ths of your neighbor's commute.
And
Yeah.
decimal, it's like,
It's bad, right?
yeah.
We don't even want the decimal for that. How are parts A and B related? When you turn around the order that you've asked for in a ratio, when you flip that order around, you're gonna end up with an answer that is, class? Well, what, the reciprocal. That's the vocab word that we actually want to use. Because look at it. Our simplified fraction for A was 40 over 3. Our simplified fraction for B is 3 over 40. Where colas are the best. Try the got it on your own. Pay attention to order. Running time to lifting time. The 2 always tells you where your ratio symbol happens or where your division happens.
When it comes to
No? I don't know. You got to talk me through the process. So what did you set up, Noah?
3 over 4 to 2 over 1.
So Noah sets up, and actually I'll start with blue. My running time was 3/4 of an hour. My lifting time, would you say came after the ratio symbol?
2 over 1.
2 over 1, because 2 hours I can make into a fraction by saying 2 over 1. So we keep change flip, right?
Yeah.
3/4. Now my division becomes multiplication because, oh yeah, this is really division. This is 1/2. I cannot cross reduce, so I get 3/8. That's it. So the running time compared to lifting time is 3/8. So you can think about that as every 3 minutes he spent running, he'll spend 8 minutes lifting. So obviously he's trying to build more muscle. If we flipped it the other way around, like maybe that person is trying to do more like distance running. Like, so that tells me he cares more about weightlifting than running. Because a lot of people just run just to get their heart rate up, and then they go and they do something else. So here's the other method that you'll see when you look on digits, and it kind of like can talk you through a problem or anything like that. Hang on to it for a second. When you have two fractions in a ratio, you can either keep change flip like we've been doing, and I'll show you how keep change flip here gets the same answer, or look at both denominators. So we have a 4 and a 7. If both denominators are not the same, find the least common multiple, which a lot of times you just multiply them by each other. Not always, but a lot of times the least common multiple, you just multiply them by each other. So 4 and 7, if I multiply by 28, so think about what we're doing. Times 28 over 1. Times 28 over 1. On top and on bottom, we would get like kind of a complex, I mean, if we didn't use a calculator, we'd get 60 plus 24, we'd get like 84 over 4, which gives me my 21. Down in the denominator, we'd get 168 over 7, which gives me my 24. Then I have to simplify. All of that, guys, we could have avoided by just doing 3/4 divided by 6/7. Keep change flip it. 3/4 times 7 6. 21 over 20, sorry, not 8, 4. In my opinion, keep change flip is the easy way to solve these. And that's just like, I've watched, like I've lived it, I've done it, and I've also watched students now for 4 years. In my opinion, if you just set up fraction compared to fraction, keep change flip it, simplify if you need to, that's the easy way to go. Solve question.
I'm wondering, would this work? Like, if your denominator is like a 1-digit number, and then your numerator is a fraction, you can just like times the denominator by the numerator's denominator, and you get.
That's what we did first. That was like the first thing on our notes. What you're describing, just multiplying by the denominator of the numerator's fraction, which is a very complicated statement to say, but that's the first thing we looked at. That was, this did capture, yes. That was this process. The numerator was a fraction, the denominator was a 1-digit number. The numerator being 4/5, we took the denominator of the numerator multiplied on top and bottom by that.
Does that work for everything?
If it's a fraction compared to a whole number, but if it was a whole number compared to a fraction, the process gets harder because now my fraction's on bottom.
Why couldn't you just keep changing?
You can.
So both of the methods.
There are a lot of right ways to get to Florida. Yep, both of those methods will work. There are.
Yeah. What ship?
You could just go around and
Try these. Notice all of these are fraction compared to fraction. So see if this is true or false. If it's false, I want to know what the right answer is.
Oh, dang.
See if this is true or false. If false, what is the right answer? That projector seems loud today.
Yes.
Yes. It does.
I think they might have cleaned out the
Projector,
air
you're
filter.
disrupting my learning.
You're breaking rule number one.
Breaking the rules, projector.
Are you out of pencils?
Yeah. I gave all my pencils to you at the beginning of the year.
Yeah.
I realized it's pretty stupid.
I need some pencils too. Yeah, I want 80 extra pencils.
So, guys, I would tell you, right about your age, I decided getting a mechanical pencil was worth it, and I would never loan it to anyone, and I would always keep it in my pocket. And I know that sometimes gets annoying, but even today, I always have a pencil or a pen or something. If I'm not at school, this kind of goes with the Boy Scout thing of always be prepared. If I'm not at school, I always have a writing utensil on me. You have no idea how many times people are like, does anyone have a pen? Does anyone have, like, I need to write this down? And like, adults in the real world don't carry, like, I mean,
Mom does.
generally, a lot of people, it'll be, like, in their notebook, or in their bag, or in their purse. When it's in your pocket, it's like, yeah, here.
Yeah.
Wait, what?
Like-
Do you carry paper with you too?
No, but I a lot of times have a post-it note in my wallet that I could jot things down on.
Oh, you can use dollar bills.
Yeah, you know, come up and show it.
Oh, sure.
Or, I mean, do you just want to talk it through? It's up to you. Okay.
Can you do the second one?
Yeah.
I do the third.
First, we
Sure.
it's right.
You gotta enunciate, speak clearly.
Is that right?
You're gonna be on all of YouTube. Yep.
Yeah, we're on YouTube.
Alright, so,
Gray Bay or something like that.
shoot. First,
No, he followed me. Yeah, or subscribed or whatever.
so, first off, so I wrote this, like, the horizontal?
Yeah.
Yeah, I wrote it in
mean-
the horizontal way, which is, like, 2, oh shoot.
You gotta pick up a pen
Oh,
and
yeah.
then use your fingernail if you're gonna try to do that.
So I did 2 thirds.
You can go ahead and do the keep change flip if you want.
Alright.
Like I think most of us can see. So it would be 2/3 in a ratio or divided by 1/5, but because I don't want him to run out of space, he can go ahead and do the keep change flip. So if I turn it into multiplication and flip my denominator fraction,
Teacher, magic.
Which is,
yep. Let's capture that so that Peyton can erase it.
You don't even need to pick up a pen. You just gotta do some writing with your fingers.
It doesn't matter.
I'm gonna write it with my feet.
Hey guys, chill.
Somebody from not in school saw it and they're like,
Oh my gosh, I'm pulling it down.
What was it?
We'll get it. Just leave the check mark. We'll get it captured at some point. Huh?
Did you ever find out where that person was from that commented on your video?
There's no way. They're just a profile on the internet.
You could ask them.
I don't
what did
care
they
now.
say?
We
What
don't know.
did
You
Wait, what did they
He's
say?
a sociopath on the internet. Posting mad filter videos. Well,
So, Peyton, when she pulled it up to the horizontal, like written out, went ahead and did her keep change flip, which is fine as long as you pay attention to the details. Sure, come on up, Lauren.
Oh wait, I took the long face.
I'm sorry, you want to do who said
Where's
it?
that?
You want to do the got it? Do the got it real fast.
where's the other markers?
Right here. Okay. trombone. They asked me to play trombone.
I played trombone. That was awesome.
So wait a minute. Already at 36 over 24. Is there any way that that's going to be equivalent to 2/3?
No.
No. What is the relationship between the right answer and the wrong answer?
The right answer is flipped.
The
Wrong answer.
The right answer is the reciprocal of the wrong answer. So whoever had solved this and got that 2/3 probably accidentally flipped their first value instead of the second value. So if we flipped this fraction instead of flipping the second one, we get the reciprocal of the right answer. So make sure you only flip the denominator or that second fraction that happens. Nate?
But can't you cancel the 9 and the 3?
You could cross reduce. Can't cancel, but you can cross reduce.
Can you do that with the 4 and 8 too?
Yeah. The whole thing could be cross reduced, just make life easier, or we can just reduce later, divide by 12. It does, like, cross reducing is just an option to save time, which depending on how your brain works, it's just as easy to reduce it later. Ellie, do you got it?
Okay, I write out 1.
So, I forget who it was asked about just make the main fraction bar longer. That's, so on your homework, in digits, that's how, when it's stacked like this, 3/4 over 9/10, the middle, the main fraction bar should be wider. It should be longer than the other fraction bars.
That was scary. Sorry. Okay. Okay. 3, 4.
So go ahead, actually, Ella, at this point, hold up. At this point, don't keep using the slash, use like the horizontal bar. So 3, then the horizontal bar 4.
Okay.
Just because then when we multiply, it's easier to look straight across the top and straight across the bottom if we use that horizontal fraction bar.
And I think it could be reduced to 5 over 6.
Yeah. There we go. 5/6 would be our answer there.
Sorry, my handwriting's
And
Can I try the next one, please? Kidding.
yeah, we're not going to get as far as I wanted today, but that's fine. Professional football field is 53 1/3 yards wide. Here's where we have to pay attention to order. Width of the actual field to the width of the field in the poster. So, it's going to be actual compared to poster. So, my actual 53 1/3 compared to the poster of 1.5. Is there an easier way to write this? They're in mix. Improper. We like impropers. 50 times 3, 150. 3 times 3, 159, but then add the 1 on. 160 over 3. 1.
Oh, 'cause you have to add-
Oh, yeah.
Duh.
Then 3 over 2. So this is really 160 divided by 3/2. I've not skipped any steps. Now we can keep change flip. Yeah? Question?
Oh, never mind. You're doing that.
So we did 53 times 3, then we added it with the 1, got 160. Now we KCF. 160 times 2/3. Not, I mean, you could try to see if 160 is a multiple of 3. It's not,
53 is
because
fine.
150 is, we know 15 and 150 would be, so 160 is not. So here it's just as easy to just multiply then reduce later. So we get 320 over 9. James?
You can simplify it to 3, 35, and 9, and 5/9.
What do you get? 35?
35.59.
Or 35.5 repeated.
Yeah.
So what that tells you is the actual football field is 35 and 5/9 times the size of the poster.
Wait.
Yeah.
How'd you get 5 nines?
320 divided by 9.
But that's 35.5555.
Yeah, 5.
Yeah, but that's 0.5 repeating is 5/9. So if we did, so think about this, if we did 315 divided by 9, that would give me 35, and I'd have 5 left over from the numerator as my remainder, 5/9.
Okay.
So you could write that or 35.5 repeating.
Okay.
Now pay attention on your homework. It'll ask for either ratio in simplest form, which this 320 to 9 might very well be the ratio in simplest form. So if it asks for ratio in simplest form, that might be the simplest form. Because 320 is not perfectly divisible by 3. And the only factors of 9 are 1, 3, and 9. So unless 320 is divisible by 9, which we see it's not, this is the ratio in simplest form. No?
On the digits homework, will they ask us to use the fraction or the colon?
I think it will accept either. Model boat.
Oh, I got this one.
You got this one? Did you already do one? Didn't you come up and do it? I was gonna let somebody else
Yeah,
come
but
up and
she
do it if
messed
they
up.
want
This is
to.
the same thing.
Pranav, do you think do you have it done yet? Take like 30 seconds to do it on your page and then come up. Nah, it's on my desk.
4 times 6. That's just 25.
So,
Oh, shoot. Oh, shoot.
you don't even have to work.
Did it.
Yeah, okay.
Oh, shoot. So it's
Not bad. But what the heck is on these lines?
Okay, what is
It's
that?
on this line. So if you come back to these notes 2 days later, you remember as good?
What?
As well, I should say.
Yeah.
Don't leave blanks on
Wait, am I
notes.
right?
You also don't leave any in your date, so if you drop them somewhere, you know whose notes they are.
Okay, I got it.
Am I right?
What
I
button?
already
My
told
button.
Pranav, you did it. Pranav, you know how to do it, do it.
Yeah, always.
Oh no, not again.
Trying to hide
Oh,
notes
this
from
is
me?
so simple. You can just look at the
Trying to
numbers.
hide notes from me?
Ow!
Yeah, you
Yeah.
can literally just look
Yeah.
at the
Why
numbers.
don't you have any work for these?
Or you could do the work. Or you should, but it's.
Yeah.
So,
And that's what you're supposed to do, even though it's like super
Well, why don't you have anything?
okay, so what I did
Oh, I
was,
just
Do it the
noticed
right way.
that.
yeah, what I did was I have 6 and 1/4, and then I had 12 over 1/2. So I converted them into improper fractions. So 6 and 1/4 equal to 6 and 12/4 would equal to 25 over 4, and then 12 and 1/2 would equal to 25 over 2.
You realize you could have cross reduced.
And then I did then from there I did 25
Hey guys, we should be listening to Pranav as he solves this for us.
times 2 over 25 because I did the reciprocal of 25 over 2. Then I multiplied, and 25 times 2 equals 50, and 4 times 25 equals 100.
Now we could have, if you chose to, also cross reduced back in there.
Yeah.
The 25s on top and bottom could cancel out. But either way, when we simplify that, what do you get as your ratio?
1 over 2, 1 to 2, or 1/2. Right?
Now here's the funny thing about all the work I saw.
You all get it wrong?
So, what you really have here with that ratio that you just solved is 1 inch to 2 feet.
Oh yeah, we did it. Yeah.
So if you want to make, because to talk about a scale factor, they have to be the same units.
But you can't make
Zach,
a
your
fraction.
hand shot up.
1 inch to 24.
1 inch to 24 inches. Now that wouldn't work if we were doing area. If we were doing area, you'd have to convert them first. But because we're only doing lengths, you can convert at the end still. So you can make your 2 feet into the 24 inches. The real answer here is 1 to 24.
See, you tricked us all.
You guys just didn't pay attention. Thank you guys. Have a great day. I will see you later.
Probably